My topic today is about firewall and QoS in enterprise network. Firewall and QoS in enterprise network. My name is Oseni Abiola. I am the CEO of Trisat Communications Limited, all the way from Nigeria. A little about me. I've been using Mikrotik RouterOS since 2005. I became Mikrotik certified consultant in 2007. In 2009, I became certified trainer, and I've trained over 500 Mikrotik users across Africa, both West Africa, South Africa, and every part of Africa. I've deployed RouterOS for wireless ISPs, corporate organizations in different horizontal markets: oil and gas, utility, banks, maritime, telecoms, even IT retail. Mikrotik has been very helpful for us. As a business, we've generated a lot of revenue from it. And as a solution provider, we've provided ultimate solutions, something that seems unbelievable with other gears in the market. One of our recent projects is for an electricity distribution company. Nigeria recently privatized electricity, the energy sector, and most of the distribution companies had been privatized presently. So some of them actually need some IT infrastructure to drive the business, especially the commercials, such as billing, such as metering, such as ERPs and the likes of it. This company invited lots of companies to come over to bid. And the model they wanted is build, manage, and support. They don't want to have any CapEx. They don't want to put down any amount of money. They just wanted to bring in all the equipment, put it in, and end-to-end connectivity is established. A lot of Cisco guys went there. We went with Mikrotik. The Cisco guys gave averagely $60,000 per month for the monthly recurring charges. And with Mikrotik, we were able to do just a little bit above half of that, about $35,000 to $40,000 a month. And today, the network spans across 4 states. The 4 states are river states and Calabar and the rest of it. The farthest is about 215 kilometers, and that's about 170-something miles. The other one's about 100-something kilometers. I think in miles, you can do the calculation. For the interstates, we leased fiber from the providers. So there's Vodacom in Nigeria, and we leased fiber with their MPLS infrastructure. Within the main city where the distribution company exists, we have about 8 business units for cash collection, complaint service centers, and the likes of it. And the network has about 23-kilometer radius. That's about 11 miles or 17 miles or thereabout. So here we use Mikrotik. We use MV2 base bus 5 with 30 dB antenna. The farthest link is about 23 kilometers, and we're able to have 120 meg on it on MV2. Latency is about 4 milliseconds. Hotboard here are the core switches and the routers. And inside here is the server farm. That's where we have the metering server. The metering server is monitoring over 1,200 servers, meters across 4 states. They also have their accounting servers. They have lots of MIS applications going on there. And we're able to provide end-to-end connectivity. Logically, the network has 3 parts: the internet connectivity, MPLS for the interstate, and we have MPLS for the Metrolink. Presently, we've been commissioned to expand the network to about 75 cash collection centers. So each of the cash collection centers may come in through any of the 3 channels to get to the data center. This has been very awesome with Mikrotik. We did everything absolutely fine. These are some of our pictures when we're setting up the network. This is the core. You can see CR1009, one as core router for boundary management and QoS between the server farm and the distribution router, because that does the QoS. Here also is a distribution router that has all the VPN tunnels and firewall policies. Okay, this is part of my team. Another recent project is for an oil and gas servicing company. All over the world, we know that the oil and gas servicing companies really depend so much on Cisco. No one wants to hear any other thing. So we approached them, and I told them, we can actually do this for half the price of whatever anyone tells you. So they went for the same model. We brought in all the equipment to put it on. Here, the company has a warehouse, okay, has a chemical plant, and has a headquarters. Okay, the HQ houses all this data. And take note, we always have limited bandwidth, because bandwidth is very expensive in Nigeria. This is one of our project sites for the oil and gas servicing company. That's the Exchange server, these MVR servers, all of them put together. We use purely 2011, and it's been awesome across board. Let's talk about the state of internet in Nigeria. Nigeria presently has about 5 submarine cables coming to Nigeria. They are Sat3, Glo1, Main1, the likes of them. All right, 5 of them landed in a city called Lagos. In the landing point, we have cost of bandwidth is a bit cheap. We call it cheap because it's cheaper than VSAT. 1 meg by 1 meg, it's about $500. Yeah, 2 meg is about $1,000. When you go to the other parts of the country, to the north, to the west, to the south, you pay extra more because there's a transit cost for the fiber between the landing point and our end point. So a 1 meg circuit ends up being about $800, and 2 meg seems to be about $1,800. So it's really expensive for us. And most of our own market, which are majorly small and mid-sized companies, could not afford much bandwidth. The highest we've done so far with most of them had been 5 meg. Because it's pretty expensive. So because of that, most of them are very, very conscious about how the internet is going to be utilized, what they need to use it for, and how they can increase their productivity. So I'm going to use a case study of the oil and gas servicing company we did recently. Okay, the company is a leading distribution of drilling and completion fluid for hydrocarbons, refineries and all sorts. So this here is the chemical plant. They produce the chemicals here and ship it down to the customer with the vessels. All right. Here, what they want to achieve is to have CCTV cameras to monitor the entire tank farm and check all the activities, especially when they are dispensing the chemicals to the vessel. And they want to be able to see that clearly at the head office without any buffering, without any delay. Also, they also involve in bulk methanol delivery. So they have warehouses. So the warehouses is where they store most of the chemicals and disperse to the customers. They also need CCTV cameras here. They want to be able to see what's going on. And here it's very important that inventory system is easily accessible so that they can actually see how the movements of stock from the warehouse to the customers. So CCTV inventory system, ERP system is very important. So from the chemical plants and from the warehouse, we did a point-to-point link with Mikrotik MV2, and we have a 60 meg circuit across board, 60 meg to 60 meg through. That's over a TCP connection link. Very awesome. And with it, we're able to go in and find out about their project objective. The project objective is actually to centralize all the line of business application, the ERP, inventory system, the MVR for the cameras and the likes of it. Also their email, because they use email a lot. So the email server is an Exchange server that's domiciled at the head office. Also, we have to deploy CCTV across the 3 locations, like I said earlier. And this CCTV must be accessible over the internet. So the business, the MD wants to be able to log on from his iPad, be able to log on to any of the cameras and see activities from any part of the world. And also within the WAN, they will also want to achieve that. They also want to optimize the WAN and internet connectivity and ensure 98.5% uptime availability. The key requirement here is also to ensure that the bandwidth is guaranteed for the line of business application. And we have just 4 meg. So with this 4 meg, we want the email server to keep going up there to get emails. We want the CCTV server to be accessed. We want Windows Update to be able to, systems to be able to do Windows Update. So we really need to optimize, the internet. And users are also going to be browsing the web, doing all sort of things. So the internet bandwidth must be fully optimized, all right? And the project goal must be achieved with the most cost-saving approach. And this is where Mikrotik actually fits in. We're able to do it at almost 45% cheaper than the leading brands. Now, this is what we designed for the client. We have 3 routers, RB2011, one standing here as a core router. It has connectivity to the internet, connectivity to the server farm, and connectivity to the HQ CCTV, and connectivity to the HQ LAN, all right? Also on it is the backbone link that goes to the chemical plant. That's a chemical plant, all right? And also here is the one at the warehouse. Each of them have the CCTV and their LAN all together. Here we have to converge all the CCTV cameras to their NVR and it must be viewed from the HQ here. And also, any mobile worker should be able to view these cameras end to end. That's what we designed logically. Okay. Here we're using OSPF and we're using MV2 for our point-to-point connectivity. Also, we make sure that we have redundancies. Okay, there's a straight flight, but here is a redundant link. So in case the straight flight breaks, then it can automatically route through the redundant link and gets to the head of it. So every point in time, you always have the cameras viewable and reachable at the HQ and over the internet. Also, the Exchange server, ERP server, all of them reside here. We put them at the central point for easy policy and also for bandwidth management. I'm going to show you that as time goes on. All right, so what's our approach to deploying this project? First thing first is, since we have to optimize the internet, we made sure that we put in advanced firewall configuration. And the configuration has 3 policies. Packet filtering. We make sure that all the unproductive traffic are taken off. It's only the necessary traffic like HTTP, SMTP, POP, and the likes of it that are allowed over the network. We did content filtering. Unfortunately, most employees want to get to the office, do Facebook, do YouTube, do some download with torrents and the likes of it. So what we're doing here with the content filtering is make sure that all those social websites, unproductive websites are blocked and just very few are allowed during the working hour. Also, we did heavy download policy. Heavy download policy involves some applications that are bandwidth hungry. For example, Internet Download Manager, download accelerators or Beats. Also, Android phones with Google Play downloads and all sorts. So when they engage the bandwidth, they usually hold on to the bandwidth for a long time, and therefore they deny the bandwidth for the line of business applications. So we're able to put in a policy that quickly identifies such device and throttles down their demand for the bandwidth. So I'm going to show you that. Then also, we made sure that we put in advanced QoS. The advanced QoS is to make sure that local traffic are unlimited, but the bandwidth, internet bandwidth are fully optimized, prioritized for all the line of business applications. Now let's go into the advanced firewall configuration, which is the main thing I want to share with you today, all right? I'll start with the tips, okay? From what I've learned from Wiki, from different presentations, and also from all of you here that are presented one way or the other, even on the forum, I found out that it's important that you have custom chains for all your policies. When you have custom chains for all your policies, it's easy for you to tweak, it's easy for you to manage. So if you want to have a chain for content filtering, create a custom chain for it. If you have a chain for router services, create a custom chain for it. Then make sure that anytime you are doing packet filtering, connection state rules are applied in all the inbuilt chains, okay? We found out that without the connection state, most of the packet filtering will not succeed because the connection state rules actually let the router be able to process new connections and establish connections. Also, make sure you use address lists for common policies. If some policies are going to be applied to a group of devices or hosts on the network, address list is usually very important. Make sure that you optimize your policy by placing them in appropriate orders. Remember, the rule of firewall is once you have matched the packet, the router stops processing the packets against every other rule. So you have to make sure you place them in the appropriate order. And finally, ensure that the guy that is protecting the host is also protected. It's very important that you protect the router itself. So these are the tips. So how did we configure the advanced firewall? What we did is, the first thing is configure the connection states. So we put that in a chain called connection state, right? We configure the rules to protect the router, so we call that chain router services. We also talk about packet filtering, so we call that custom chain allowed services. Those are services that we're going to allow on the network. And we called content filtering, we call it restricted sites. Okay, we try as much as possible to use a name that is easy to come by so that the administrator can easily manage the network afterwards. And we'll configure the rule for the heavy downloaders, so we'll call the chain heavy downloaders, okay? Then, after that, we jump from the inbuilt chain to the custom chains. We jump from the inbuilt chain to the custom chains, okay? Then afterward, we find out that there are some hosts on the network that need exemptions. Okay, the boss wants to be able to view all the sites without any restrictions. So we learn how to put exemptions on our configuration through address list. Now let's start. Now, for the connection state, this is how it goes. All right, we created a chain called connection state. You can see chain connection states, and these are the output on it. Chain is connection state. You drop invalid connection, allowed established connection, and allowed related connection. That way, the router will be able to process new connections itself. Now, the second thing is router services. What we did with router service, like I told you, we create a custom chain. For router services, these are policies that are going to protect the router. Most of the time, we've fallen victim of DNS spoofing or DNS attack. Because our router runs DNS cache. Some guys, wherever from China or wherever, just spoofs the network, spoof the internet, realize that our router could help them to resolve the, the names. So therefore, they pointed all their DNS to our routers. And what happened? All the uplink was consumed, and the network was extremely slow. That means our router will go to the internet, resolve the name on their behalf, give them the request, and keep doing it in a round-robin manner. So our uplink was completely consumed. So what we did is we put in router services as a custom chain, then we drop DNS attack. Please take note of the in interface. The in interface must be your one because you are protecting the router from the internet. So you must specify from what port, from what interface are you protecting the attack from. So in interface is one. We also try to drop FTP 2021. We drop Telnet as well. We drop Webbox. For some of you that are also Mikrotik guru that want to do some Webbox into our routers. Then SSH and the likes of it. So we keep updating the router service. So as much as we found more attacks coming to the router, we just come to this custom chain router services and keep updating, and it's very, very easy. The next one is allowed services. Presently in that router, we have over 50 ports and protocols that are allowed over the network. So I just shortened some of them. The most common one are HTTP, STP, HTTPS, POP, DNS. Please always remember the golden deny rule. You must place deny rule after you have allowed most of the required traffic. Okay, so the golden deny rule you must drop everything else. If you don't do that, you will not be able to actually have an effective packet filtering. Okay, drop everything else. We found out that doing this, we're able to drop lots of excessive traffic. right? Restricted sites. With restricted sites, we had to use two things: layer 7 protocols and filter rules. Okay, layer 7 protocols allows us to have the regex expression. Okay, reg expression of most of the traffic, and most common one for the website is this. Okay, I got this on Wiki, got it on forum and some other blogs. And thanks to Greg, he has some good regex on his website. So so we had to put them together as well. So what you need to do is any sites that you really don't want them to access, you come in here, click the plus sign, this comes up, copy this out, just put the URL of the website in between the brackets. Okay, if you want Facebook, just do that. If you want YouTube, just do that. That's all. Click apply, okay. But make sure you give it a name that you can remember. A name that you can remember. If you have populated your layer 7 protocols, then you can go to filter rules. Remember, we created another custom chain called restricted sites. So all the sites that we want to restrict, they are all here. So we just come to the filter chain. Chain is equal to restricted sites, advanced, layer 7 protocol, you choose. Okay, so you keep doing that for all the sites that you want to do. And action is usually drop. Okay, action is drop because you want to drop them. Also, if you want to make it a little bit flexible, probably you want to block them during working hours and allow them to be able to do whatever after closing hour. You can use a time matcher in the advanced tab. You specify the time and it's going to stop them. Now, the heavy downloaders, these are always the smart guys. You know, they use part of the traffic we have allowed in the allowed services, most especially HTTP and at times HTTPS. Some of the most wicked among all is Internet Download Manager. So it splits the connection. Look at it. It wants to download. Here, a file of 134 MB is about to be downloaded, but it splits the connection into several connections and it's using port 80. So since it is port 80, our firewall cannot stop it because it's a regular port. It's a regular port. So you can imagine on a link as small as 4 MB, someone is downloading 134 MB of traffic on it or data on it. You can imagine what's going to be of that link. It's going to be very slow. That means all the line of business application will be denied very good internet. So that way will be affected. Also, we found out that in most part of Africa, we use Android. In Nigeria, we use Android a lot. So the Android guys are always going up there, updating apps, downloading apps, and also. So because of that, they engage the port 80 as well. So using the port 80, it affects the little bandwidth that we have. Another important thing another problem we found out on the network was Windows Update. You found that most of the system wants to do Windows Update. But for another discussion, I'll tell you the solution later. But what we did basically was to set up an Active Directory server and have what we called Windows Service Update Server, something. Okay, so, and we use group policy to direct all Windows updates to the Active Directory server. And we made the Active Directory server to always go and check for Windows update during off-business hour. So that way the bandwidth is available, the Active Directory server can download all the updates and keep it local. So everyone keeps going local with Active Directory server. But how did we solve it with our own policy? We created two policies, two rules here. The first rule says that if you get anyone downloading straight down up to 25 MB on the network, then such person is doing something that is unacceptable. If you're downloading up to 25 MB of data at a stretch, then you are doing something unacceptable on the network. So if you are doing something unacceptable on the network, this rule said, then pick such IP address and keep it in an address list called heavy downloaders. Okay, keep it in an address list called heavy downloader. And that's why you see all these guys here with D on them. These are guys that that are downloading up to 25 MB at a go. So this could be an Android phone, this could be a server, this could be anything. So far, you are downloading at a straight 25 MB, then you're going to be trapped. And we said such host should be held down for 2 hours. 2 hours. So So that's the only way we're able to know those that are abusing the network, because definitely they won't be able to browse the internet. They have to call us and say, hey, I can't browse the internet. Then the administrator says, hey, yeah, you're a bad guy. You're not doing the right thing on the network. So, but in some companies, with some of our clients, some don't want that. What we did was use the same technique and use Mangoro, then put all those culprits in a small pool of bandwidth. You can actually tell them, you can actually use Mangoro and say, Mangoro, pick any address list here, any IP on this address list, mark the connection, then put it in a small pool of bandwidth. So we did that for some of our clients that don't want to be stopped, but they just want to be slowed down. But some said, please block them off. At least let me know that they are not doing something productive. So for these clients, they just want to block them off. So they block them off for 2 hours, okay? Then this second rule is very important. You have to place it above the second one, the second one. That is, if you have found anyone in address list called heavy downloader, okay? Drop such guy. If you found anyone in address list called heavy downloader, then action, drop. You have to place this above the rule that is catching them. The reason is that the rule needs to match first, they needs to be dropped first before they can get to the next rule. All right, so if you are not within this, then you go to the second rule. But if you are within this already access list, then you are dropped. Okay, after 2 hours, you have your internet back. And truthfully, most of the staff actually found out that they are going to be stopped for 2 hours. So everyone stopped downloading. They stopped downloading because they don't want to stop working. Yeah, so now let's connect the dots together. The rule states that you have custom chain, but custom chains are dormant until you connect them to an inbuilt chain. The inbuilt chain here are input chain, forward chain, and output chain, right? So we need to connect both the custom chain and the inbuilt chain together for all our custom chain to become effective. So we use the rule that is called, we use the action called jump. Jump is what you use to jump. Now, as you're creating your custom rules, you have all of them listed here, all right? Both input, output, all of them, you have them listed here. And you have, if you click all, you're going to see all your rules, including all their chains and the likes of it. Now, in the input chain, remember I told you, connection state is very important because if you are doing protection for the router or packet filtering, connection state is what's going to process new connection, all right? So in our input chain, we need to jump to connection state. Then in our input chain, we also need to jump to router services. That is where we have the policies that are protecting the router, isn't it? So what we did is create the first rule, jump to connection states. Okay, jump, then connection state. All right, then the second rule is jump, then jump to router services. So this way, we have told the input chain, okay, what the rules to apply to every packet as they are coming into the router. All right, then excuse me. Then in the forward chain is where we will do most of our jobs. Okay, that's where we want to do the packet filtering. That's where we want to do the content filtering. That's where we want to penalize all the heavy downloaders, right? So we put the jump rule. The first jump rule is jump to heavy downloader. So as a packet is coming in through the forward chain, it's being scrutinized against heavy downloader. So if you are within the list of heavy downloaders and address list, then you're dropped. Okay, the second one is restricted sites, all right? With restricted sites, the content filtering takes place, so we jump to restricted. And please take note of the in interface. For this to really work, you have to specify your in interface. But what we did here is, because we have lots of local interfaces, we only specify not one interface. So that means that if you see any traffic coming from the local interfaces, jump them to what? The restricted sites, okay? If where they are going to is not listed in the restricted site, then allow them to go. But if where they are going to is listed or prohibited in the restricted site, then drop them. So the next thing is connection state, okay? Without connection state, most of the packet filtering will not work. So connection state is, and take note that we are using the same connection state we used in input, It's the same connection state we're also using in forward, because it's a custom chain. We're just jumping to it, and make sure that all the packets are scrutinized. The next one is torrent, okay? Well, this is optional. The packet filtering have already done the job, but some torrents are smart enough to, to do some encryption, so they can just sniff the network, see the allowed ports, and go in through the allowed ports. Okay, so we just use some expression in layer 7 to describe some torrents like eDonkey, Kazaa, and the likes of them, BitTorrents. Then the next one is jump to allowed service. This is where you do all the packet filtering and you move them. All right, so that's how to do advanced configuration. You create your custom chain, then you link them to your inbuilt chain. All right. So we found out also, despite we have all these restrictions, that there is need for us to have exemption. So we saw exemption in 3 places. Exception is in the download chain, heavy download chain. Okay. Exception in the restricted chain, and exception in the allowed services chain. Okay. We also found out that we could create some exception in forward chain as well. But for you to create some exemption, you have to use address lists with firewall filter rules. Okay, so let's look at what we do with exception for heavy download. We call them HD exception. Okay, what we just did is some of the bosses and some of the senior staffs, they don't want any restrictions, so we took their IP, okay, and put them under the address list called HD exception, and we went to the rule in the filter that drops them, okay, and we say not HD exception, not HD exception. That is, if you're counting connection of 25 MB for every host, all right, make sure you don't count for those in HD exception, not. Please take note of this as exclamation sign, not, right? Let's look at what we did for restricted site. For restricted site, we put some IPs in address list, call it allowed address list. Then we went to the rule that is restricting the site, and we say accept. Now, let me tell you why we use this strategy. Each website has its own rule. Facebook has its own rule. YouTube has its own rule. So they all have their rule. In order for you to bypass the entire set of rules, we created a single rule called an accept rule. Okay, that's why we placed it at the top, accept rule, right? And we said source address allowed. That is, if you see anyone within the source address called allow, don't bother going down to scrutinize them. Just let them be, okay? But if they are not in allow, then you have to go down there and scrutinize them, okay? The same thing for in the forward chain, okay? What we found out in the forward chain is that because we have lots of local interfaces, okay, we try to tell the firewall that if there are local traffic, the local interfaces moving traffic across board, they don't apply any packet filtering, because we have large bandwidth in our LAN, we have large bandwidth in our WAN, so we really don't need any restrictions. So we use interface-based exemption, okay? And we said when the in interface is not 1, that is when it is local. When the out interface is also local, then accept. Let them pull any kind of protocol, let them pull any kind of port number, let them do any kind of thing. Let them push any kind of traffic. That's what it means. So we use interface-based exemptions in this case. Then in the forward chain, what we found out with the forward chain is we also wanted our server farm to be accessed without any restriction, okay? So that if you want to access the ERP, access the inventory system, access every other server, do not apply any rule, because it is internal. So what we did was to create a separate chain, okay, in the filter rule. We call it forward chain exception. Okay, then we put all the destination subnets right there, okay? Then the next thing we did was to place it above all the forward chain rules. What this means is that if anyone is getting from the LAN or from any sector of the network to the server farm, all the rules on the forward chain are not applied to them. All the rules on the forward chain are not applied to them. So We jump from the forward chain to that forward exception rules, and that's all. So with this, we're able to protect the internet efficiently, and we reduce or filter out all unwanted traffic, and also create policies within our local traffic, within our server farm, and to the rest of the local internet. The next thing that we did, which was very important, is quality of service. With the quality of service, we use simple queue. And we did two different things in simple queue: speed limit and quality of service. Speed limit and quality of service. A lot of administrators or a lot of Mikrotik users don't know the difference between speed limit and quality of service. Most people that I see in the forum actually just do what is called speed limit. You have a 100 MB Ethernet interface, then you say target host 2 MB, target host 3 MB. What you are doing there is you are saying out of the 100 meg on that Ethernet interface, I'm giving this host 3 meg. I'm giving this host 2 meg. So what you're doing is purely speed limit. You're just trying to speed limit the 100 MB. But quality of service actually means that you tell the router the amount of bandwidth that you have, and you tell the router how to prioritize and use the bandwidth for the hosts. That's what quality of service is all about. And you are able to guarantee bandwidth at peak period for certain hosts. That's what quality of service is all about. And I'm going to show you that now. In the deployment, we have simple queue that is doing speed limit. But in this case, we are doing unlimited speed because it's a local traffic, isn't it? So we don't need to penalize it. We want them to enjoy everything local at the speed of light. So what we did was look at the target. Most of the target here is the server farm. This is exactly the server farm. That is, if you're targeting the server farm. And if the destination, that is when the server farm responds, when the server responds to your request, if the destination is any of our WAN or the HQ LAN, then make it unlimited. That's what this rule is all about. So what we have done here is speed limit, but quite fortunately, it is unlimited. But if we want to limit it, we could have just put something in limit at, and it's just going to limit the 100 MB to certain bandwidth that we specify. Okay, so this is speed limit in its essence. Okay, then the next thing we did was to look at the bandwidth, the internet bandwidth critically, and manage it and optimize it for the applications. All right, so what we did here is called HTB because it requires HTB. HTB here is you're saying to any destination, we have 4 MB. 4 MB up, 4 MB down, right? So the router is aware of the total bandwidth that we have, all right? And this now becomes the parent to every other child queue that we have here. So now we said out of the 4 MB, let the server farm have 1 MB, okay? Let the server farm have 1 MB. Out of the 4 MB, let the warehouse have 512, okay? Let the chemical plant have 768 kbps, and let the HQ have 768 kbps, all right? But close to the office is a residential building, all right? So this is a residential building, and we said let them also have 1 MB. But we know that because it's residential, they'll always be at work all the time, so that 1 MB will still be used by all. Remember, this is a CIR. We made sure that during peak period, when everyone needs internet, this is what everyone gets. This is what every sector of the network gets. But when some part of the network is idle, then they can burst to 4 MB. Okay, for example, let's say, let's look at what happens here. Look at it. HQ presently is using 2.4 MB, right? It's because the rest of the network is idle. HQ is using 2.4 MB. CP is using 748 kbps. And the rest are idle. So they are able to use the bandwidth. But if the 4 of them are actually using the bandwidth at the same time and heavily, this is what they'll be limited to. So this way we are able to make sure that at peak period, the line of business application have a very good bandwidth, all right? And at less peak period, the rest of the network can use the rest of the bandwidth. This is what QoS is all about, okay? And take note, priority did the job. If you don't put priority here, the router will not be able to guarantee bandwidth for the line of business applications. That's why we said the server farm should have priority of 1. That is, at peak period, make sure you can guarantee 1 meg out of that 4 meg for the server farm. Then let other contend for the rest of it. All right? And we also said, let the chemical plant and head office, the HQ, let them have second priority, because the HQ needs internet for all their inventory and all of that. And the chemical plant also needs to send mail to their clients, when they are boarding, when they are doing all sort of things. So we make sure that those are the next line of guys that could use the internet efficiently. And the third one is the warehouse. The warehouse is just for stock taking, stock keeping, so they really don't need much. So we put them at priority 3. And the house, the residential home, we put them at priority 8, because most of the time they are also going to be at the office. All right, so with this, we are able to optimize the internet and make sure that line of business applications are accessible all the time. That's the end of our adventure with the oil servicing project. Any question? Question? Yep.
What if for the content filtering, what if someone types HTTPS? Still do that?
Yes. Yes, because we're using layer 7 protocol. Because we're using layer 7 protocol, even if you use HTTPS, it's not going to flow, because it's using the expression, the reg expression for YouTube. So it's not going to fly. What you said usually happens when you're using web proxy. With web proxy, you said HTTP, YouTube should be dropped, denied. Then the smart guys will just put HTTPS, then they find their way. But with layer 7 protocol, no. It's a reg expression, so it's a signature, so it's not going to fly. It's not going to fly. More question? Okay, questions? Okay, in case you want to reach me, in case you have a project about firewall and you want to deploy something similar to this, or in case you use some of the scripts on the presentation and have a problem with it, you can reach me on any of this channel. Our website is www.trisatcom.net. My email is abiola@trisatcom.net, or Gmail, all of forever. You can also call me, and if you have a project in Nigeria, you can tell your clients to come to our office to see us physically. Forgive me, I could have put my Skype ID in case you want to add me on the Skype. Maybe I should quickly do that. You can reach me on Skype, HAB Hollow 1. Yeah, you can also reach me on Skype. You can, so we can work together and build a more robust firewall. But for some of you that are more advanced with this, like Dennis, like Greg, there's a problem we have with the download accelerator. We found out that the download accelerator, let me tell you the flaw here. The download accelerator, okay, is downloading a 25 MB data, for example. It splits it into 8 connections. Then that means that 25 MB divided by 8 turns to about 2-point-something MB, all right? So if your heavy download rule is saying 25 MB per TCP connection, then IDM is able to bypass that, because each TCP connection is not up to 25 MB. So we look forward to tweaking it. Maybe I'll put it on forum, then we can actually see what we can do with that. And if you try to go down as low as 2 MB for each TCP connections, a lot of people will get caught by the heavy download. So, but the only way we're able to pacify ourselves well is just 25 MB coming through IDM. It's just going to take a few moments, then the download will stop. So it's not really 100% foolproof with some tools. So, but we still have to find a way around it to actually limit it the best way we can.